This video is about solving systems of equations, specifically using substitution. So before we talk about solving systems of equations using substitution, I'd like to talk about solving systems of equations in general. So when we talk about a system of equations, we're talking about two equations that should be solved simultaneously. So if we look at the first equation, y equals minus 3x over 2 plus 4, we can graph that by plotting the y-intercept of 4 and then counting our slope down 3 and over 2. It's going to put us right here, and graphing our line. So again, we plotted the y-intercept of 4 and we went down 3 and over 2 for that first line. For the second line, we're going to do the same thing. We're going to make it plus 6 up here, so we'll assume that our scale continues. We'll go down 5 and over 2, and we will draw that line. And what we're looking for here is where the two lines intersect, and I'm hoping that you can see in this particular case that they intersect at the point 2, 1. So keep in mind, that's what we're doing when we're solving a system of equations, is we're looking for where the lines cross. You should also remember that lines don't always cross, so if you end up having two parallel lines, you'll have no solution. And if you have two lines that are actually the same line, just one on top of each other, then those two will cross everywhere and you'll have an infinite number of solutions. So for our first example here, we have two linear equations. We're hoping that these two linear equations cross somewhere. And in order to find out where they cross algebraically, we're going to use the method of substitution. So we're going to start here with this equation here, 4x plus y equals 9. And we'll subtract 4x from each side. So we're going to get y equals 9 minus 4x. So this is now what y is equal to. We're going to plug it into this first equation. So the idea here is to solve for one of the variables. Very easy to solve for y in this case. So we're going to plug it in and get 3x minus 2 times 9 minus 4x equals 4. And then we'll use some algebraic skills. Minus 2 times 9 is 18. Minus 2 times minus 4 is plus 8. X, so 3x and 8x is 11x. Minus 18 equals 4. We'll add 18 to each side. We get 11x equals 22, so x is equal to 2. That's only half of the solution. We're going to find the other half by plugging the 2 into one of the original equations. So I'm going to go ahead and use the first equation, 3 times 2 minus 2y equals 4. 6 minus 2y equals 4. If I subtract 6 from each side, I'll get minus 2y equals minus 6, and y is equal to, let's go back a little bit. Minus 2y equals minus 2, so y is equal to 1. So our solution is an ordered pair. The ordered pair is xy, so in this case the ordered pair is 2, 1. So for this example, you'll notice that it's not very evident on whether or not we should solve for x or y, and the truth is it doesn't matter, but it's not as clear as it was in the previous example where the coefficient of y was 1, so it was really easy to solve for. So here, I'm going to start with this minus 5x plus 2y equals 9. And I'm going to go ahead and solve for y again. It really doesn't matter, I could solve for x as well. So I'm going to add 5x to each side, and I'm going to get 5x plus 9. And when I divide through by 2, I get 5 halves x plus 9 halves. Now remember, what I do with this is I'm going to plug it into this other equation for the y. So up here, I'm going to say 9x minus 4 times 5 halves x plus 9 halves equals negative 17. So we now have to distribute this 4 in to this set of parentheses. So we get 9x. If I distribute, minus 4 times 5 is minus 20 halves. Minus 20 halves is minus 10x. Minus 4 times 9 is negative 36 halves, so that'll be minus 18 equals minus 17. So collecting like terms, we get minus x. If I add 18 to each side, I get equals 1. And I get x equals negative 1. So the solution, oops, that's just half the solution, right? So we get negative 1 comma something. And the question is, where do I get that something? Well, I'm going to plug this x value back in here to one of the original, and it doesn't matter which one I choose, I'm going to choose the first one. So 9 times negative 1 minus 4y equals negative 17. Negative 9 minus 4y equals negative 17. Negative 4y equals, if I add 9 to each side, I get negative 8. So y is equal to 2. So my ordered pair, my solution here, is negative 1 comma 2.